Hello everyone, welcome back to my channel. I'm Dnyaneshwari Bhosale, and today we are continuing our series on cybersecurity. Let's dive into Symmetric Algorithm. So, data encryption standard, that is DES. Data encryption standard takes 64-bit plain text as an input and creates 64-bit ciphertext using 64-bit per block. So, the plain text is divided into size of 64-bit block, each and encrypted with 56-bit key at the initial level. At the decryption side, DES takes 64-bit ciphertext and creates 64-bit plain text with 56-bit key. So, as we can see in the figure, 56-bit key at initial level is been uh, converted into ciphertext. So, DES uses 56-bit key, but actually initially the key is of 64-bit. Before DES processes, every 8-bit of key is discarded to produce the 56-bit key. So the figure where you can see discarding of every 8-bit of original key is been done. So, data encryption standard is based on two fundamental attributes of cryptography. First is substitution and second is transposition. So, DES consists of 16 steps, each of which is called as a round. So, each round performs steps of substitution as well as transposition. So here are the steps of the rounds. So firstly, a block size is of 64-bit. The number of rounds to be held is 16. The key size is of 64-bit. So the number of sub keys is 64 sub keys. Sub keys is of 48 bits and ciphertext is of 64-bit. So firstly, 64-bit plain text block is handed over to an initial permutation IP function. The IP is performed on plain text. So if a IP produces two halves or permuted block, firstly the left plain text and the right plain text. Each of left plain text and right plain text go through 16 rounds of encryption processes. In the end, the left plain text and right plain text are rejoined and the final permutation is been performed on a combined block. The result of this process produce a ciphertext of 64-bit. So here is the step performed one by one. Plain text of 64 bits is been done initial permutation. Then two left plain text and right plain text is done of 32 bits each. Both perform 16 rounds. Then left plain text of 32 bits and right plain text of 32 bits is been processed, and the final permutation takes place and the ciphertext of 64 bits is been occurred. So, initial permutation. It happened only once before the first round, rearranging and shuffling each bit, that is called as transposition. This process is called jugglery of bit position. After initial permutation, the 64-bit PT block, that is plain text block, get divided into left plain text and right plain text. So here are the permutation table of DES, that is initial permutation table, inverse initial permutation table, expanse permutation table, and last one is permutation function table. Details of one round of DES. Firstly is key transformation, then expansion permutation, X box substitution, P box substitution, and XOR operation. So the rounds, key transportation, key transformation. So 56-bit key is used during encryption, and 56-bit key is transformed into 48-bit key, discarding every 8-bit of initial key, that is 8, 16, 32, and so on. From 56 key, a different 48-bit key is being generated during each round, and the process is called as transformation. Here is the DS key scheduled calculation. First is input key permuted choice 1, permuted choice 2, and schedule of left shifts. So expansion permutation process. We had two 32-bit left plain text and right plain text. In step 2, write plain text is expanded from 32-bit to 48-bit. The process is called as expansion permutation. During this process, the bits are being permutated as shown in the next figure. It is clear that 32-bit of write plain text get expanded with 48-bit, which is XORed with 48-bit key. This resulting output of XOR operation is given to the next step, which is called as S-box substitution. So here's a single iteration of DES algorithm. So, S-box substitution process is accept 48-bit key and expanded write plain text of 48-bit which get XORed and produce 32-bit and produces 32-bit output. This substitute is performed by 8 substitute box called S-box. S-box performs just jugglery substitute one each bit positions and produce compressed bits. The substitution performed using 8 substitution boxes. The reason called as S-box. So here is the S-box substitution. Firstly, it expands 32-bit R to 48-bit using expansion permutation E. Then it is XORed by 48-bit K and expanded R both 48-bit. So S-boxes 8 of strings to 32 bits and permuting using 32 bits. So P permutated box. 32-bit output from 8 S box is then permutated by P box. So the output of S box is input of P box, which 32 bits are permuted using straightforward permutation mechanism. This is replacement of each bit with another bit is the specified table called as P box permutation. XOR and swapping. The output of P box get XOR with left plain text that is 32-bit and produce new 32-bit right plain text. Output of XOR operation becomes new right plain text and the old right plain text becomes the new left plain text. Complete process is called as XOR and swapping. So here's the P box permutation. The same information is being there in the this slide. So lastly, the final permutation process. Last operation is permutation of 32-bit left plain text and 32-bit plain text that is produced by XOR and swapping operation. Final permutation was performed after successful completion of 16 rounds. Inverse of initial permutation is also called as final permutation, and this process produces a 64-bit ciphertext. So let us see the advantages of DES. Ideally suited for implementation of hardware, bits, shift and lookups, etc. Dedicated hardware could run DES. Technique well suited for voice and video encryption. 56-bit key means 2 raised to 56 is roughly 7.2 into 10 raised to 16 keys required to break DES cipher. The disadvantages are trying all possible combination is not much hard these days. So it could be easy to break down this process. So two chosen input to an S box can create the same output. So the purpose of initial and final permutation is not so clear. Let us see what is double DES. It is perform the same operation as of DES. It uses two keys that is K1 and K2. First is perform encryption on plain text which encrypted using K1 obtains first ciphertext. Again, this ciphertext is encrypted by using another key called K2 and converted it into final ciphertext. That is PT gives K1 bracket PT EK2 gives EK1 bracket P and ciphertext gives EK2 EK1 and PT. Triple DES. So this is performed as same as operation of double DES. It uses two keys that is K1, K2 and also K3. First, it is performed encryption on PT which encrypted using K1 obtains first ciphertext. Again, this ciphertext is encrypted by using another key called as K2. Again, this ciphertext is being encrypted by the key called K3 to get the final ciphertext. And here are some of the formulas that are done in the processes. So the key comparison of symmetric ciphers on penetratum second. Cipher DES key length is 56 and speed is 9 Mbps. 3DES, that is key length is 168 and speed is 3 Mbps. RC2, that is key length is variable and speed is 0.9 Mbps. RC4, that is key length is variable and speed is 45 Mbps. So that's it for this video. Thanks for watching this video. If you found this video helpful, don't forget to like, share and subscribe to my channel. Drop your questions or topic requests in the comments below and stay tuned for the next video on our cybersecurity series. Until then, stay safe and stay secure. Thank you for watching.